All right, river problem. Some people struggle with this, so I'm going to go through it. I'm going to videotape it. That way people can reference it. I don't have to teach it 50 times. So, here we go. You are going to canoe across a river from the west side to the east side. The current will push you south at 3 feet per second. Your canoe is capable of going 10 feet per second in still water. The river is 800 feet wide. How long will it take you to cross the river if you try to head due east? Okay, if you try to head due east. So that's the key, the part that says if you try to head due east. So here's your river. Let's say this is our starting point. You try to head due east. Okay, so you try to do this. While you're doing that, what's the current going to do?
Push you 3 feet south.
Push you south. Okay? So you're trying to do this at 10 feet per second, while the current is pushing you south at 3 feet per second. Okay? So then, obviously, the black vector there is your resultant. Okay? Now, you had to look at what's being asked of you here. Okay? It says, how long will it take you to cross the river if you head due east? You do not have to solve for any part of this resultant whatsoever here. You can, but there is no reason to. Okay? The river is 800 feet wide. That means the distance from one shore all the way to the other shore, that is 800 feet. Because your canoe is moving 10 feet per second horizontally, it will simply take you 800 feet divided by 10 feet per second to figure out how much time it takes you to get across the river. Okay? You don't need to figure out your resultant magnitude. The reason that wouldn't be beneficial is because you don't need to figure out the total distance you would travel at an angle. You could, okay, you could, but there's no reason to. In 1 second of time, you will have moved 10 feet across this river. Yes. You will have moved more than 10 feet total, but you're 10 feet away from the shore that you started on. You're downstream a little bit, but you're 10 feet away from the shore. So really, because it's 800 feet across, divide that by the rate that you're moving across, which is 10, it will take you 80 seconds to get across the river. You're taking a horizontal distance divided by a horizontal rate to get how much time it takes.
I thought we had to accumulate the fact that you're being.
You could do what you did. I remember what you did. You found this hypotenuse. Then you found that angle. Then you found the distance that it would go diagonally.
Yeah.
And then you divided that by the magnitude of the black one. Which if you don't round, you probably get correct. Okay? But there is no reason to do that because you know the horizontal distance, you know your horizontal rate. Divide those, it'll tell you how much time it takes to get across. Okay? And then part B, how far downstream will you end up? Well, in 1 second, you get pushed 3 feet downstream. And if it takes you 80 seconds to get across the river, and every second you get pushed 3 feet downstream, 80 seconds times 3 feet per second would equal 240 feet. So you did not have to calculate your resultant in those first two questions. You could have, but you would not have to. If I said, what is your resultant speed and direction if you try to head due east, that's when you got to find the magnitude and the angle. But I didn't even ask that. Okay? So that would be the quickest way to do A and B. All right? All right. C. if you decide to cross the river directly to the east by aiming your canoe 9 degrees north of east, how far will you miss your destination, and will you be upstream or downstream from your target? Okay? Old picture. Get rid of it. Gone. Not happening anymore. You will not draw that right triangle in this situation. Alright? So we're starting on the west bank. We're trying to head directly east. To try to head directly east, this was our goal. Alright, this dotted line, that was our goal, to head due east. We decided to aim the canoe 9 degrees north of east. So we decided to aim the canoe 9 degrees north of east. Assuming there was no current, okay, or our canoe is capable of going 10 feet per second in still water. So this first vector is what the canoe is going to try to do. Okay? We know that won't be the resultant though. Okay? That would be if this was a lake, then there was no current, all right? But we're in a river. So the canoe's trying to go 10 feet per second, 9 degrees north of east. The river is pushing you south still at 3 feet per second. Now, I don't know exactly how to draw this. Okay, I'm totally guessing. We don't know if maybe this is the right angle. Maybe this does end up being a 90-degree angle. I don't know. We'll figure it out. But I'm not drawing it as a 90 because I don't know that it's a 90. I'm going to assume that I'm still going to miss my target. So there's my resultant. Okay, the black one would be the resultant. So I'm going to aim this way. Current's going to push me this way. The black one's my resultant. Okay? Let's figure out the missing parts of this triangle so that way we can answer the question. Okay? Missing parts of the triangle. Well, if this is 9 here, remember that how that was 9 degrees north of east? This would be 90, this would be 81 degrees up there because in that top right triangle, 9, 90, 81, that adds up to 180. Okay? At this point, I could use law of cosines to help me find that distance there. So c squared equals 10 squared plus 3 squared minus 2 times 10 times 3 times the cosine of 81 degrees. .98067. Actually, it ended up being .678 if I rounded to that many places. I'm going to try to use my previous answer button. But, okay. So my resultant, this canoe would end up traveling at a rate of about 9.98 feet per second. Okay? Now let's figure out the angles in this triangle. Okay? I could figure out this angle here, or I could figure out this angle down here. I'm going to go ahead and figure out this angle right there. Well, I'll call it theta. My setup would be sine of theta over 3 equals sine of 81 over c, over that 9.98. Right? Law of sines. Okay? So do a little cross multiplying and dividing. So 3 sine 81. Divide that by c. So Divide that by my previous answer. Then I'm going to inverse sine that answer. I get about 17.27. So theta is about 17.27 degrees. So this angle in the triangle is about 17.27 degrees, which is clearly bigger than 9 degrees, so I actually drew my picture a little bit to scale. Okay? So what that tells me then is that while I aimed 9 degrees north of east, I still ended up traveling 17.27 minus 9 is about 8.27 degrees. I still ended up traveling about 8.27 degrees south of east. So I still ended up missing my target because this angle here was larger than 9, and I ended up traveling that many degrees south of east. So now, if you think about it, if I ended up traveling at 8.27 degrees south of east, if I continued on that path, I'm going to end up being downstream this far, right? Well, don't I know my distance across the river? So I can do tangent of 8.27 degrees equals opposite over adjacent, which in this case was 800. I could use this big right triangle here that is formed by the path that I wanted to take. I know I ended up moving 8.27 degrees south of east, so I can use this right triangle here, solve that for x, and I will figure out how far downstream I missed my target. About 116.3. And that would be feet downstream. Okay? And then lastly, part D. At what angle would you have to aim in order to travel directly east across the river? So now again, a brand new picture. If this is my resultant, then I need to aim obviously upstream while the current pushes me downstream, making the blue one my resultant, right? Yeah. Well, remember, the boat can try to go 10 feet per second while the current is pushing me back downstream at 3 feet per second. So if I want my resultant to be directly across the river, I just need to find out that angle, inverse sine of 3 over 10. Inverse sine of 3 over 10 would give you that angle. So about 17.5 degrees north of east. That's the direction I would have to aim in order to actually travel directly across. Okay, there is the river problem.